But that's not something that we were ever allowed to pass on or to publicize. And now we can.
The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and software test professionals, we welcome everyone today to this webinar on advanced software testing, integration testing. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS is based in the United States with partners around the world. We deliver insight and confidence to our clients, helping them get quality software and hardware products to market on time with a measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. We have helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to their customers. I am the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, Managing the Testing Process, and Fundamentos de Pruebas de Software. First book on the ISTQB certification in Spanish, and the first book in any language aligned with the 2011 Foundation syllabus. I have a degree in computer science and engineering from UCLA, and I'm the past president of the International Software Testing Qualifications Board and of the American Software Testing Qualifications Board. RBCS is presenting this webinar in partnership with Software Test Professionals. In addition to our ongoing collaboration on webinars and training, I will be the opening keynote at the Software Test Professionals Fall Conference, October 25th in Dallas, Texas. That is next week. So I hope to see many of you there. In addition, if you haven't checked their association website, take a look. It's www.softwaretestpro.com. It's Software Test Pro, all one word, no spaces. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, please do submit them at any time via your webinar interface. I will look at those later during the Q&A session. Please note that those are not checked while the main presentation is going on, but rather during the Q&A session at the end. There is no need to ask for presentation copies. The presentation is on the web, rbcs-us.com. Go to the resources selection in the middle of the upper middle of the website, and then select the basic library, and then basic library, and you will find the slides there. You also don't need to ask about how to register for the free e-learning. Simply by attending this webinar, you are automatically registered. Check your email over the next couple days, watch the spam filter, and make sure that the notification doesn't get lost there. You do have a limited amount of time to respond if you are the winner. If you are having problems with either the audio or visual components of this webinar, please contact GoToWebinar support. If you cannot get to the webinar online, or if you're dealing with an unreliable connection, the best approach is to download the slides from the basic library, as I said, on the rbcs-us.com website, and then use the telephone to connect rather than voice over IP. You'll be able to follow along in the slides. We do occasionally have some problems with that. Most of the time they seem to be company firewall issues that prevent people from getting there, though we have had some reports of browser compatibility problems. New versions of IE, for example. I guess Citrix is not big on doing browser compatibility testing. So if you are having problems, one thing to try is perhaps if you've got an alternative browser installed on your PC, try that. Hope you enjoyed this free webinar from RBCS. We do these free webinars monthly as a service to the software testing community, because at RBCS we're a not just for profit company. Today's presentation is about software testing, or excuse me, about integration testing. Thanks to the advent of lots of tools and the popularity of agile ideas, unit testing is certainly being done a lot better lately. System testing, system integration testing, and user acceptance testing, I think, are well understood. But integration testing has long been and still remains the forgotten test level, so today we're going to remember that level, why it's important, and ways you can organize it. Material in this webinar is adapted from my book, co-authored with Jamie Mitchell, Advanced Software Testing Volume 3. That book is a book that's targeted for technical people, technical test analysts, programmers, and test engineers. So I hope you find this material to be stimulating and interesting. If you are not particularly technical person, you might find it a little challenging. There are some concepts that do sort of presume an understanding of how software is implemented and how it communicates internally. So with that said, let's take a look at what you should know about integration testing. So first off, let's talk about integration techniques. Now, I'm setting aside for the moment this concept of continuous integration, which is common in the Agile world. Let's assume for the moment we're talking about a sequential lifecycle model. I'll come back to continuous and how the continuous integration would affect this discussion here in a moment. So assuming we're doing a sequential lifecycle model, in other words, the units are being built one by one and integrated together over time, then there are a few ways of approaching this. So one is what's referred to as top-down integration. So what we do, let's get the pen out here and see if we can kind of help illustrate this a little bit. You think of an application as consisting of a series of layers in many cases, where the upper layer here is the UI, and then down here at the bottom you've got sort of the hardware, and harder to write with your finger on a touchpad than you might think, hardware / OS / database level at the bottom, and then there's some number of business logic layers in between. So you see up here, it says layers of business logic that are actually implementing whatever sort of problem solving needs to happen. And there might be more than two. There could be any number of layers of business logic. So in a top-down integration approach, what you're going to do is you're going to start up at the top, logically enough, and you're going to work your way down like this. Now, that you could have conceivably four what are sometimes called builds. So the first build might contain the entire UI and checking that the entire UI integrates properly. The second build might then have the entire UI plus the entire top business logic layer. Let's highlighter. This guy here. And then the third build checks the UI integrated with both the top and the bottom business logic layers, pointing at the bottom one here. And then the fourth build would include the all of the business logic layers, the UI, plus the hardware and operating system and database stuff at the bottom. So that'd be one way to do it. That'd be an example of a top-down approach. Now, that's a fairly coarse-grained approach in the sense that there are only four builds. You do not have to integrate an entire level of the architecture at once. What you can do is, say, break down some of the levels into sub-levels. Like say there's a certain part of the user interface that is customer facing, and so you start with the integration testing of that one first, and then you add on the system administration user interface pieces. Then you add on the business logic at this layer that has to do with customer facing pieces, and then add on the business logic at this layer that has to do with the system administration features. And then same here, customer facing versus business or versus system administration features here, and then maybe this layer all at once. So then we'd have 7 builds, which, you know, a little finer grained, if you will. And the thing about the finer grained integration approach is that when you go to test that, if you find a problem in a given build, you know that the problem was introduced in either the new modules that were added to that particular build, or in the relationship between those modules and modules that were in a previous build. The isolation of the defects is much easier. Okay, so that's top down. We talked about coarse grained or fine grained. I see that when I just did that, it blew out my diagram for some reason. Well, let's go ahead and restore the diagram to some extent. Again, this is UI up here, business logic here, more business logic down here, and then it's hardware down here. Okay, so we can also do what's called bottom up, which logically enough, what we're doing then in that case is starting at the bottom of the application architecture, hardware operating system, and database layer, and then moving upwards. And again, it can be, we can move upwards in a coarse-grained fashion or a fine-grained fashion in terms of, you know, how many total builds do we want, and what portions of each layer are introduced in each build. And it's not the case that you have to define the number of units or modules that will be introduced in each build. You don't have to be that rigid. You can define some way of some logic or strategy that you're going to use. You can also use what's referred to as a sandwich, which is where we start producing and testing builds from the top and the bottom simultaneously. Okay, that's sandwich approach, ultimately meeting in the middle. Now, another approach that can be used, it's not a very good idea, is what's called the Big Bang, which is you wait to integrate things until all of the code is done and unit tested. This is just another manifestation of a classic worst practice of testing, which is testing on the assumption that nothing is going to go wrong, and that's exactly the opposite of the assumption that the tester should bring to the process. We should assume that things are going to go wrong and we're going to find problems. And as soon as you make that assumption, you then come to the next logical conclusion, which is it would be good to find the problems as soon as possible, which means that we should start integrating right away. Now, so we can basically rule out this guy as an approach and say, okay, well, what's of these three here, you know, pros and cons? Well, I said you want to start testing right away, right? So, I mean, one of the influences here has to be where do you think the code's going to be available? I mean, if you think the lower layer stuff is going to be available first, then that would push you towards doing a bottom-up approach. If you think that the top layer stuff, the UI, is going to be available first, then that would push you towards top-down. And if you think that the business logic will be the last stuff completed, and the hardware, software, OS stuff, and the UI stuff will be completed at roughly the same time, then that would push for a sandwich type of approach. Now, of course, that all leaves out a very important consideration here. We're talking about when stuff is going to be ready and available to test. That does not necessarily correspond to the order in which one would like to test it, which of course would be in the order of risk. So that is something that's worth considering here. Is you know, if you're in charge of component integration testing and you're having a conversation with your development management colleagues and project management colleagues about the integration technique that you want to follow, make sure that the discussion is not just about, well, what are you going to have ready for me as early as possible, but also, you know, what in a perfect world, based on the level of risk, the likelihood and impact associated with failure of particular modules, what would we test first, and make sure that's part of the equation. That should influence the order in which things are built. Now, of course, one of the obstacles that you're likely to run into as soon as you have that conversation is, well, the harder stuff to build is got a higher likelihood of failure, and it might be more critical from an impact point of view, but it's also, we don't want to rush it, and it's going to take longer. So, you know, it's often the case that there's sort of a trade-off that you get into in component integration testing, and I've run into this myself a number of times. That just you end up testing things almost in the exact backwards order of that you would want to do if you were doing pure risk-based testing, just because the stuff that's most risky is the stuff that takes the longest to get done and is thus integrated last. But this is that is certainly no argument for Big Bang, because even if that's the case, even if the last build contains the largest number of high-risk modules, from a project risk point of view, it makes a lot of sense to get all of the other dross, if you will, out of the way, the defects and problems associated with the less risky modules, before you dive into that testing of the more risky stuff. You certainly do not want to be distracted by trivialities when you're trying to test the riskier stuff. Now, this brings us to this issue of the non-shippable code, so-called stubs and drivers. Now, a stub is a piece of code that replaces something that is called by the module or modules that you're trying to test. So you think about, if we're testing the UI up here, and the business logic layer does not yet exist. So this stuff is non-existent at this point, right? Say we're using the sandwich approach. Okay? So we're sandwiching. Business logic doesn't exist, but we got UI, we got the hardware, software, or hardware operating system and DBMS layer available to us. Okay, so the UI code, it's got calls going down basically into this layer, right, into this business logic layer. Okay, so though it's going to be trying to call things that are not available, going to call modules that are not available. We need to, in order to test the UI, replace those modules with some kind of dummy module that allows the program to execute and does just enough to sort of fool the software that we're testing, that the UI layer, that things are functioning. It might be used to actually drive specific return values to the UI to test the way the UI handles certain types of conditions. But that's all that does. That's referred to as a stub. It's a dummy piece of code. It's non-shippable code. It allows the code above it in the hierarchy or the architecture to be executed, but that's all it does. Now, what's a driver? Well, let's think about down here, the hardware layer. You know, the hardware, software, or hardware operating system DBMS layer is going to be receiving calls from the layer of the architecture above it. Well, but that doesn't exist at this point, right? The business logic isn't there. So we have to have some way of actually calling the modules that we're trying to test in that hardware operating system and database management system layer, and those are referred to as drivers. Okay, the drivers put some sort of wrapper around the modules that you're trying to test and allow you effectively to transfer control in there to invoke them. Now let's kind of pop out to a few related topics here. One is this drivers and stubs. You might say, you know, I don't hear that term. Well, if you're in an object-oriented world, you might actually hear a related term called a mock object, which is the same kind of thing as a driver or a stub. It's replacing an object that doesn't exist. So that's the analog there. And then a lot of times people are using open source or freeware tools like, say, JUnit or NUnit. That has the ability to basically put this wrapper around the module or modules that you're trying to test in isolation, and thus serves as a sort of a universal driver, if you will. Now, I said we're going to put off for a minute discussing what happens when you're doing continuous integration, and so the minute has arrived. Let's say you are in a agile world, and what's going on is that code is being created and integrated into the main line of the software repository, you know, in real time, basically, as it's being written. So what does that do here? Well, at this point, it kind of depends on the order in which the software is being written as to what that means with respect to the integration technique that's underway. I mean, people are working on, the programmers are focused primarily on hardware, operating system, and database layer stuff first. Then it would be effectively bottom up, and if you're focused on UI first, then it'd be effectively top down. Though typically, what we would get is focusing on implementing a particular piece of functionality, which would be referred to as a user story in the Agile terminology, or perhaps use case, and that would have components potentially at all layers of the architecture. So that's another form of integration that is not driven by the architecture or design of the system so much as driven by the functionality, so it's sometimes called functional integration. So it's quite likely that what you would be seeing is a form of functional integration that's going on, and thus the testing would be functional integration testing. So that's another possibility that you might encounter. This has been more introduced by this idea of these building in iterations, and this is not just for Agile. It would also be true in any iterative life cycle. Now then, the question of, okay, I get stuff, I get functions, user stories that are completed, so forth. So what do I need to do? Well, basically what you'd have to do is look at the way that the pieces that make up that function integrate with other pieces in the existing system and test integration of those. And I think what happens all too often is that the focus is entirely on the user story itself, its functional attributes, perhaps its non-functional attributes, but the extent to which that integrates with other parts of the system might very well not be addressed. So, again, this is a level of testing, integration testing, and it's something that should be considered. So, whether you're doing it at the same time as you're doing the system testing of the completed function or use case or user story, whatever you want to call it, that's fine. But if you remember, if you leave out testing the integration of that code that makes up that module with the other parts of the system that already exist, you have exposed yourself to some interoperability risks that could come back to haunt you later. Okay, so in terms of this integration approach, to discuss this, as I said, the process is incremental. The coarseness or fineness of the granularity of it is determined by the number of builds that will happen. Each build is assumed to be unit tested before it is introduced into the integration, and this would of course be true in continuous integration in an Agile world as well. And as I said, if something fails, you should look to the pieces that were added most recently, either the pieces themselves or their relationship with other pieces. Reasons why people aren't too wild about the classic techniques, and I think one of the things that sort of pushes people towards the idea of continuous integration and Agile sort of model is that it's good for the project manager because it provides multiple checkpoints that say, okay, yes, this is coming together, but there is potentially a lot of overhead associated with it from the stubs and drivers and the builds that have to be created and tested. So the price paid for the risk mitigation is sometimes seen as too high, though, again, it's often the case that people underestimate the likelihood of problems. So that's a mistake that you don't want to make. Now, you also want to make sure that you understand what kind of problems you're going to find. Excuse me. Integration testing should be focused primarily on the interactions between the components or units. It's not about trying to do some sort of form of system testing. These are separate levels and they have different objectives. So don't make the assumption that you necessarily, who've done the integration testing of something, that there aren't going to be any other problems to find. Now, there's another form of integration testing, which instead of looking at the architecture from a purely hierarchical point of view, actually examines the modules and their relationship between them. And the idea is to try to reduce the amount of drivers and stubs by focusing on, when we have pairs or groups of interoperating modules, let's test those, and then we're not creating these stubs or drivers. Now, stubs and drivers might be created as part of the unit testing, but that can be done, as I said, with an open source framework of some sort. There are two basic approaches to the call graph integration. So one is what's called pairwise, where we identify the interacting modules, pairs of them, and make sure that we test each of those interactions. So that makes sense, pairwise, right? What pairs can interact, and have we tested them. Then there's another one that's called neighborhood integration, where we're going to identify groups of modules that interact, and we're going to wait until those are ready, and then we're going to test those all together. So on the left-hand side of the screen here, we see the pairwise approach, and let me get the highlighter going here. Let's say that we have modules 16 and 9 are ready, and 17 and 18 are ready, and 22 and 24 are ready, and those two talk to each other. Those modules talk to each other. As you can see, 22 calls 24, 17 calls 18, and 16 calls 9. Then we would test those in pairs, and then let's say that 10 becomes ready, so we would immediately test 16 and 10. If 11 became ready, then we would test 17 and 11, and so forth. We would just continue along, basically looking for, as soon as we've got a pair of modules that talk to each other that are ready, both of the modules are ready, we're going to test them. Now, obviously, that creates a fair amount of integration testing sessions. The alternative here that's shown on the right-hand side of the slide is the neighborhood call graph. Let's take a look at how that works. See, in the neighborhood, we say, okay, 1, 16, 9, 10, and 12. That's a neighborhood, and and we can probably assume that they do something. Right? These 5 modules implement some sort of capability. And so what we're going to do is we're going to test the integration of those modules by testing that capability that they create. And then we might find also that this grouping over here is likewise a neighborhood, and so we've identified this neighborhood and then we test it. Excuse me. The important thing would be that this continues, this testing, the identification of neighborhoods and the testing of those neighborhoods continues until every one of these arrows has been two things. One, present in some sort of neighborhood. So in other words, that the relationship 21 to 23, that's an arrow, right? That's been present in some sort of neighborhood. And 2, that some test has been run that forces the important interactions that can occur through that arrow to have occurred. In other words, what I mean by having conditions 1 and 2 there is it's not enough for just to have it present in the build. You actually have to make sure that you did indeed test that relationship. And notice now, in this case, no stubs, no drivers being created. Now, that's sort of a simplification because when I say no stubs, no drivers, it's possible that you do need to put some amount of stub or driver in place, but it should be very lightweight. And it's, again, if you're using one of the frameworks, open source frameworks, then that should definitely minimize the amount of work. Now, there's another piece of information, piece of the puzzle here that we need to look at, which is to say, well, okay, we talk about testing the interaction. I said, you know, the arrow has to be represented in a build, and the tests have to be such that that interaction that exists along that arrow has been tested, right? So then the question would be, well, what would it mean to adequately test it? So Tom McCabe, the guy who came up with the concept of cyclomatic complexity for looking at complexity of individual units, also came up with this concept of integration complexity and integration basis paths and basis tests. So what he was looking at there is, you know, what would it mean to sufficiently do integration testing between some set of modules? And he defined something that he referred to as design predicates, which are basically the design predicates are ways that two modules can relate to each other, and each design predicate has some level of associated integration complexity, which also is associated with the number of tests that we would need to run for it. And the design predicates are combinable. So the relationship between one unit and another will always include at least one of the design predicates, but it might actually include more than one, which would mean that the coverage necessary to test the relationship between those would be a composite of those design predicates, which I'll explain here in a minute. Now, as with McCabe's cyclomatic complexity, there's this concept of the basis paths, which in this case has to do with the type of design predicate that exists between the two modules, and then that translates into the basis test, which in this case is, you know, do we test that relationship? Okay, so here are the design predicates that I referred to. I apologize for the somewhat wonky and academic sounding name, but the simple way to think of this is just the type of relationship between one unit and another. So let me go clockwise here, starting at the upper left through these different predicates here. So we have the first one here labeled A. This is an unconditional call. Unit 0 always calls Unit 1. So if you have a piece of code where there is a function or object that if you get into the code here that's in this unit, that function or object will always be invoked no matter what, that's called an unconditional call. And notice that there's a 0 there, which basically, that doesn't mean you don't need to test that, but what that's saying is that there's no need for any additional testing, because if you invoke Unit 0, you will necessarily be invoking Unit 1. So that's the unconditional call. Moving on to the design predicate that's labeled with a B, this is the conditional call. So this is Unit 0 might or might not call Unit 1, depends on some condition. A condition might be based on a parameter that's passed into Unit 0, could be based on a calculation that Unit 0 does itself, but whatever the reason, there are circumstances under which Unit 1 will not be called and circumstances under which it will. Now notice that the notational aspect here is that they put a little dot on the head of the arrow there, indicating that it might or might not be called. Okay? And the design predicate complexity count here is 1, which makes sense if you think about it, because what they're saying is that in addition to testing the situation that you would have here where unit 0 is called and unit 1 is also called, you have to test the one additional test that involves unit 0 being invoked but unit 1 not being invoked. Okay, so that's conditional. Then we have E, which is the iterative call, okay? And that's a situation where unit 0 will call unit 1 at least once, but it might call it more than once. And that's got a 1, and it's from a notational point of view. Notice the arrow going there, that indicating iteration. And so, you know, there's a 1, and the 1 indicates we got to test it where unit 0 calls unit 1 exactly once, and then we have to test it, you know, which is again back the same over here, the unconditional call. But we also have to test it where unit 0 calls unit 1 some multiple number of times, where, you know, in the ideal case is it would be the maximum number, though that might or not be possible for you to make that happen. Okay, now we get into sort of combinations of design predicates, so let's illustrate those. This first one labeled F. This is what's called the iterative conditional call. It's a combination of the iterative call and the conditional call. This is a situation where unit 0 might not call unit 1 at all. It might call it once, or it might call it multiple times. Okay, so you notice you got the dot and the arrow here, so it's a composition of the two, and then, you know, it's this plus that. Right, 1 plus 1 is 2. So that's how the composition works. Here we have an uncompositional one. Here we have 3 unconditional calls. Unit 0 calls unit 1, unit 2, and unit n, whatever that number is. Notice that it's just the sum of these 3 design predicates, and then it's still kind of integration complexity count of 0. Because if we call unit 0, then these 3 units will necessarily be called. Now here we have the mutually exclusive conditional call. Okay, and this is a situation. This is a new design predicate here. This is a situation where unit 0 will call unit 1 or unit 2 or unit n. And it will not call more than one of those. It will only call one of them at a time. So then in that case, the integration complexity is n minus 1. So if it's 3, the integration complexity is 2. Which basically means that in addition to having a test, which you would already have, where you call unit 0 and that results in unit 1 being invoked, you'd also had to add a test for unit 0 invoking unit 2 instead, and for unit 0 invoking unit n instead. Okay. So those are the design predicates. Now here is a piece of code that will actually work. If you've got a Linux box, you can try this out. It does need to be Linux or Unix or something like that, because it uses interrupt handling. As you can see down here, interrupt handling is used to do some of the calculations. So basically what this piece of code does is it takes a input from the keyboard and it converts that input into the value, the numeric value that's represented by the hexadecimal portions of it. It's a hexadecimal character converter. And you notice that it has this capability here that it's setting up, where it's basically saying if you give it an interrupt, which on a Unix system is a Control-C character, if you give it an interrupt, what that's going to do is it's going to invoke this pop H digit, which is basically going to back out the last hexadecimal number that was entered. So if you accidentally enter an F when you meant to enter U in the character string, and you just hit Control-C, and that would pull the F out and effectively undo it. So there's a chunk of code here that converts decimal digits, and then there's a chunk of code here that converts the lowercase hex digits, and a chunk of code here that converts the uppercase hex digits, and then this piece just forgets it, skips the others. And once it gets done doing this loop, in other words, you've sent it all the characters you're going to send it, it either gives you an error message because there weren't any hex conversions given, or it says, okay, I got this number of digits, and here's what that number is. Okay, so if I diagram this using the design predicates, I can say, okay, here's the main program, and then here are the pop h digit function, and then those main and pop h digit being the two things that I've defined, those also call signal, long jump, set jump, get char, printf, and fprintf. Now, let's try and go through this here. I've just labeled these A, B, C, D, E, F, G, H for convenience of representation. Also to look at the basis paths, which we'll do here in just a minute. So what's our integration complexity? Well, if you look at the end, let's go back here, we see that either fprintf or printf will be called, but not both of them. That can't happen, and there's definitely one or the other. So that is a conditional, mutually exclusive conditional call where n is 2, so n minus 1, 2 minus 1 is 2. Okay, so that's this part here. Okay. Let's go back over to the left side here. Signal. This is a iterative relationship because you notice that main is always going to call signal at least once. It calls it here, and if signal is not equal to sig eigen, then for the SIGINT signal, if that doesn't say, okay, we're ignoring that, then it's going to call it again. Right? So that's a simple iterative. Okay. Now, pop h digit, this is a conditional iterative because if the signal call does return sig eigen, pop h digit will never actually get called. But if this is not, and there are multiple control C's received, then it'll get pop h digit will get called as many times as a control C is received. Now, whenever pop h digit is called, it will definitely call signal, and it'll definitely call long jump. So you can see here that those are unconditional calls. Now, set jump, it's a conditional. Set jump will get called at most once, and it only is called if signal returns something other than sig eigen in that situation. So that's a basic conditional call. Set jump might get called once, might not get called at all. Get char, that's iterative. It's not conditional iterative. It'll definitely be called at least once. Now, if it's given a blank input, in other words, end of file, and it doesn't get anything, it returns end of file the first time, then it got called only once, but it could get called dozens or hundreds or thousands of times, depending on how long the input string is. Okay, so we have our design predicates here with their associated integration complexity counts, and that's basically you add those up, and then you add 1. That's the integration complexity, is the sum of the design predicates plus 1. That gives us 7. Now, you might be saying, well, what does the 1 mean? Well, the 1 means you got to have at least one test, right? So here's the way to think about it. Suppose that the relationship between main and pop h digit and the things called by main and the things called by pop h digit, let's suppose that those were all unconditional calls. Okay, then the sum of the integration complexity design predicates would be 0. And you basically only need one test to do the integration testing, because what would happen there is that would force all of those relationships to be executed and exercised. And so you would have tested out the calling of each of those. Now, the thing with the basis tests, it says basically saying you need at least 7 tests. Actually, what you generally find if you try to employ McCabe's integration technique is that you're going to have, you need fewer than the number. It's basically it's at least, but not exactly. So, for example, if we input A, just an A, then we'll call A, B, B, E, F, F, G. So A, B, B, E, and then F, get the A, F, get a end of file, and then G. Okay, that covers that. Then the next one here is saying A, B, F, H, so that's just a, that's A, and it gets sig again, so then it calls F, the get char gets an EOF, and it goes to fprintf, right? Let's see, then here we have a longer string. We're going to give it an F, a 5, a caret, control C, popping out the 5, a T, a 9, and an A. So we should get F9A coming out. And then we can input a really long string that's got a bunch of control C's, and you get some sort of appropriate return result there. And that will allow us to go through and check as we go along our coverage. So what you would do to check your coverage is when you run a test, if it's one of these unconditional calls, you just mark this arrow as covered, right? Let's suppose it's a conditional call. Well, then you execute a test where it does call, so you mark the arrow as covered, and you execute a test where it doesn't call, you mark the dot as covered. For the conditional, or excuse me, for the iterative, it's, you mark this line when it's called once, this line when it's called, this arc when it's called multiple times. Mutually exclusives, you just mark each one of these as they're called. Conditional iterative, you would mark this line when it's called once, this arc when it's called more than once, and this dot when it's called 0 times. And you basically just repeat that until every one of the lines, arcs, and dots has been highlighted, and then at that point you're done. And as I said, you'll often find that it's fewer than the integration complexity number. Okay, so that's a quick overview of the different integration testing techniques and concepts. This test level is one that is very frequently forgotten. I'm hoping that this webinar will help motivate people to start thinking about it. I think one of the things is that people sometimes confuse test level with period of time, which is it's a problem that I'll admit having compounded myself on occasion by referring to test levels as test phases, because that sort of indicates that you're in one phase or another. Now the reality is that you could very well be carrying out 2 levels at the same period of time. So let's say that there is no specific dedicated period of time in which integration testing will be done. You might say, well, then there's no integration testing level. That doesn't necessarily have to be. You could say, okay, we're in system test from a schedule point of view, but we're also going to carry out an integration test level here because I need to make sure that these things work properly, these modules work properly together. And this applies to the Agile life cycles as well. If there's continuous integration going on, make sure that, as I mentioned before, that you're thinking about how these modules, as they're added to the code base, interact with other modules. And that's not just, I'm not just talking about end-to-end testing here, though that's certainly important, that there needs to be at some point a sort of an end-to-end test where people are looking at how things work together, which I don't think happens anywhere near as much as it should. But also just very narrowly focused tests where you sit down and do a technical analysis of these are all the different ways in which these modules interact. And this object can invoke these other objects, etc. And make sure that those have been tested, because a lot of undiscovered, interoperability problems will lurk in those areas if you have not tested them out. And this is an important part of making sure that integration defects are not discovered late during system test or system integration test or acceptance testing, because as I've certainly mentioned a number of times in these webinars, the cost of a defect and removing that defect escalates as the project continues. So it behooves you to get those defects out as quickly as you can. Okay, so put the advertisement up here as always. Go into the conclusion of the presentation and a Q&A session. Let's get the question pane undocked here. So give me just a second to do that. All right, we had somebody comment here, someone who regrettably has left. They were unable to get audio. They didn't have any sound at all. There is a post on the blog, the RBCS blog, that talks about how to fix these audio problems. And generally what happens is that there's a Windows audio setting that's not set up correctly, and you can either be really loud with a lot of echo or not audible at all, which sounds like this is the case with poor Bob here. But anyway, go to the RBCS blog. If you go to the RBCS website, you can go to blog, which is at the right-hand side, and do a search for webinar or audio, and you'll find it. The trick of fixing this was discovered by a fellow named Avner, who I've acknowledged in the post. He's a frequent listener. So for those of you who did find the audio a little bit less than perfect, I'd say give that a shot next time. So I had a question here from Kathy saying, on the design predicates, would there not be an additional model for mutually conditional calls, multiple conditional calls that are not mutually exclusive? Okay, sure. Let's go back and look at that. Show you how that works. Try to get this darn Q&A. Yeah, okay, get this panel. I have more going on my screen than I can handle. Okay, so what Kathy's referring to here is the possibility Unit 1 might or might not call, or Unit 0 might or might not call Unit 1. It might or might not call Unit 2. It might or might not call Unit 3, etc. So what would that look like? Well, the way that you would show that, and again, pardon my really horrible drawings here, but this is really tricky to do with your finger on a touchpad, I can assure you. Let's say that there are 3 units that might or might not get called by Unit 0. Unit 1, Unit 2, and Unit 3. Okay? And so the way you show it is like this, right? So Unit 0 might or might not call Unit 1, so that's a conditional call. Unit 0 might or might not call Unit 2, that's conditional call. Unit 0 might or might not call Unit 3, that's also conditional. Unit 0 might call 1 and 2, but not 3. It might call 1 and 3, but not 2, and it might call 2 and 3, but not 1. Or it might call all 3 of them, 1, 2, and 3, or it might call none of them in this situation, right? So what's the integration complexity? Well, it's 1, 1. Okay, so then the total there would be 3. Now, you might say, well, wait a minute. So we just identified a number of interesting combinations there in the sense that we have none of them are called. We have 3 different, exactly one of them are called, right? 1 but not 2 or 3, 2 but not 1 or 3, 3 but not 1 or 2. and then we've got 1 and 2, 1 and 3, 2 and 3, and then we've got 1, 2, and 3. So that's a total of 8 combinations. You might say unique combinations, and that leaves out order too, which who knows if that could be different. But let's assume that the order is not a variable here. But we say, look, there's 8 different combinations there. But you're only saying you need 3 tests. Yes, because what we're doing here ultimately is a form of equivalence partitioning, where we're saying that there are interesting equivalence partitions on the call-er, call-e relationship, where this is the call-er, right, and these guys down here are the call-es. Okay, we're doing equivalence partitioning on the call-er, call-e relationships between pairs of units. We're not looking at collections of units together and doing an analysis on the possible multiple ways that those things might interact. So that's why it would be 3 rather than 8. Okay, question from Faris. From your experience, Rex, what is the biggest challenge during the implementation of integration testing? Wow. Okay, so from a management point of view, Faris, the challenge is just getting people to do it. Getting people off of that, oh, everything's going to be fine, we don't have to worry about that assumption. That's really the hardest part management-wise. Now, from a technical point of view, you know, there can be various challenges that arise depending on what you're dealing with, right? I mean, I remember on one particular project, one of the big challenges we had during the integration testing had to do with the test environment, because we had counted on somebody to set up a test environment correctly, which, you know, I should have known better than that. Anyway, this person, you know, not part of the test team, not somebody who was going to suffer the consequences if there were problems. This person set up the test environment incorrectly, leaving an important license uninstalled, and this caused an incredible number of false positives to occur when we were trying to run our tests. Really confused the results of the test and created a lot of grief. I mean, the number of person days lost was unbelievable. So, you know, they can be, you know, shooting yourself in the foot, or somebody else shoots you in the foot, problems with the environment, which definitely, you know, if it's a brand new system, you're likely to have some environmental issues, so you got to be careful with that. There are often tooling considerations here, so if you're testing through APIs, you probably want to have some sort of harness set up, and that harness is very helpful in terms of automating the tests and so forth, but it does have to be created. So that has been a problem in the past for me. On projects that had custom hardware, and so the integration testing was a hardware-software integration test. There can be issues with supply of the hardware. It can be, in a lot of ways, a very complex level of testing, one that really requires a lot of careful technical and managerial consideration. It doesn't tend to just go well. It's not the kind of thing you just sort of, oh, gee, you know, we're in component integration testing and this is going so smoothly. That's kind of an unusual experience. Let's see. So Diego asks, it's clear that bugs found during integration are more cost efficient than ones found during system testing, but what would you think if time and budget permits to complete full system tests, functional testing, or do risk-based functional testing with some integration? Which would you pick? Well, I mean, we're always constrained, right? So if you're saying I've got time and resource constraints, would I rather do more testing at the system test level versus less testing at the system test level plus some amount of testing at the integration test level? I think that's pretty straightforward. I'd take the integration testing with some potentially limited amount of system testing. Yeah, I'd be happy if, like, let's say that I had a total effort cap of let's say 500 person hours on testing for whatever reason. That's what was budgeted, and that's all I could spend. But I could at my option get involved, spend some of that time on the integration testing prior to the system testing starting. Yeah, I would definitely want to do that. I don't know how much. I mean, it might be 100 of the hours get spent that way, 200 of the hours maybe. I would think it would be less than the amount of system testing. It would depend on what type of system I was testing, of course. But yeah, I would. I mean, risk in terms of risk-based, yes, I'd always want to do some amount of risk analysis and use that to determine what I could test, both in integration testing and in system testing. But yeah, I want to get the defects out earlier. I've just had too many problems come up where, you know, things that hadn't been integration tested got thrown into system test, and pain and unhappiness followed. Because effectively what you're doing, if you allow stuff that hasn't been integration tested to be dropped into a system test, is you're doing a form of Big Bang integration testing. You know, this is the first time people are looking at it from a test point of view is when it's in system test, and that can result in a lot of blocking issues and such. Let's see. Faris asks, if you don't have a testing environment available, how would you perform integration testing? Not testing it in production. Hard question, I guess, he says. Well, yeah, I mean, you're going to need to have some sort of test environment available for integration testing. Could it be done in the development environment or in the build environment? Yeah, that's a possibility. You know, obviously, you'd have to get agreement from the owners of those environments to let you do that. But that's certainly possible. And you know, in an agile world, a lot of that stuff does go on, and people have continuous integration harnesses built up, and there are integration tests being run through those harnesses. Then that is where the component integration testing is happening. Let's see, Faris says, hope you'll answer at least one of the 3 questions I posed. I believe I've answered them all now, Faris. I don't see any other questions from you. Oh, I see. Here's another one. Yes. How can the information about integration testing help us while preparing the test plan? Well, when you're writing your test plan, you should be thinking about, you know, what's within your scope as a test manager or tester. And if integration testing is not in your scope, then find out whose scope it is. If it's not in anybody's scope, then I would say that's a problem. As I said, if you don't get, if you go in a system test without anybody having done the integration testing, you're basically doing a form of Big Bang integration testing, and that's not usually a good idea. So, you know, figure out if nobody owns it, then basically you do own it as the test manager. So figure out what's going to go on with integration testing, who's going to own it. As I said, if nobody owns it, assume that you own it, and plan accordingly. You know, you'll need to get resources, you'll need to get time, you need to get sufficiently technical people on your team to be able to understand what's going on from an integration point of view. But yeah, don't just ignore it and go, oh, that's somebody else's job, I don't have to worry about that, because, you know, testing, you're downstream from everybody else, and so if the integration testing doesn't happen, it's gonna land on the testing team, both feet. Let's see, I got a question from Daniel. Do you know any software which would generate the integration complexity metrics, or maybe more of the software which would generate tests for us? Okay, so there's a program called BattleMap that's sold by McCabe, and I assume that does generate integration complexity. It ain't cheap, Daniel. You know, if you can afford it, if you got the budget for it, you can get it, but it ain't cheap. But that will do the integration complexity. Now, as far as generating the tests, I have from time to time in my career seen various tools that purported to do test generation, and the problems with those tools are one of the problems is the test basis problem. What are the tests based on? Okay, if the tests are based on the requirements, then they would obviously have to be machine-readable requirements, and that would impose certain conditions on the writing of the requirements, which I think is a big assumption because our clients almost uniformly, they all have problems with getting any kind of decent requirement specification at all. And to say that not only do we have to get a requirement specification, but it has to be complete and it has to be to this format that's asking a lot. In other cases, the tools use the code itself as a test basis. That's certainly, you can do that. And there are like commercial tools like the Parasoft tool set will generate tests from the code, input values and so forth. And that gets you then into the second problem that you have, which is the test oracle problem. How do you know the correct result, expected result? And if you're generating from the requirements, maybe the requirements say, maybe they don't, but they probably don't say everything that should happen, and they certainly don't say everything that shouldn't happen. So that then is still not going to be generated from the tool. If the expected results are generated from the code itself, then that's really weak in my experience, because only the most obvious of statements can be made by generating tests from the code, like, the application shouldn't crash, or, if the application always returns 0, if it's passed a parameter whose value is 0, then you'll get 0 back. But okay, that's what the code says, but is that what it's supposed to do? So I don't personally put a whole lot of stock in the generation of tests. I mean, I think the tools like Parasoft's tool that generate the tests, that could be a useful place to start, but you should plan on augmenting those. Daniel has another question here. Should integration tests consist of the unit tests? No. No. The unit tests, well, maybe no is too strong a word. Typically the unit tests themselves will not suffice. And the reason is that the unit tests are not designed, usually they should not be designed, to explore the relationship between the unit being tested and other units with which that unit interacts. The unit tests are designed to understand and check the operation of the unit itself and to test that unit's inward focused. Integration tests are outward focused. Now, sometimes it's as a byproduct or side effect of testing a unit, you can't help but test the interactions, but that's not something that you should assume. I mean, when integration testing, your focus is outward focused. It's interactions between units, not operations within units. Let's see, another question from Daniel here. What do you think is an integration test as a task for developers or for testers / QA? Yeah, as I said before, someone has to own it, then if nobody owns it and you own the testing and the testing comes last, guess what? You own it, because it's like, I mean, you think of software projects as being kind of like a river, okay? And there are people that are upstream of you on the river. Business analysts or requirements engineers writing requirements, and architects or designers doing design work, and programmers creating code and hopefully unit testing that code. And think of, defects, you can think of those as like garbage being tossed into the river, some of which floats and some of which kind of rolls along on the bottom and is less visible. At every step along the way, the people upstream are to some extent throwing garbage into the river. They can't help it. It's not that this is, the metaphor kind of breaks down here. This is not a willful act necessarily. It's just people make mistakes. Now, the thing that does have to be willfully done is that people have to understand that part of software engineering is making mistakes, so garbage is getting thrown into the river, so the garbage has to be taken out of the river. So if there are steps included along the way that people are doing to take the garbage out of the river, then what gets to you ultimately is a lot less garbage, and it takes a lot less time for you to clean that out. Now, if steps are being skipped, including integration testing steps, then you're going to get more garbage. Now, the thing with integration testing as a step, if it's skipped, I referred to garbage that floats along the top. That's like kind of functional problems that are fairly easy to see, versus garbage that rolls along the bottom, like a broken beer bottle rolling along the bottom of the river. Those integration problems are very likely to consist of a disproportionately high number of garbage that rolls along the bottom. So it won't just jump out at you. You won't see it unless you go looking for it. But it's there, and it's potentially quite bad news, like the broken beer bottle on the bottom of the river, waiting for somebody's foot to come along and step on it. So I really think it is something that needs to be done. So let's see. Navigate through the list of questions that I have here. Daniel says, I think I do not have a budget for the battle map tool. Well, sorry, Daniel. I think a lot of people don't have the budget for that kind of tool. But, the technique is one that I think is fairly easy to understand. Basically what it's saying is if you look at the relationship between two modules, it's not enough to just have a single test where one module calls another, right? You want to say, okay, what are the different relationships that can exist in terms of conditional calls and iterative calls or conditional iterative calls and so forth, and have I done those variations? And I don't think you necessarily need the tool to do that. Let's say Ferris asks, did you ever use Parasoft's virtualization? What do you think about simulation of external environments in order to test a component? When you say Parasoft virtualization, I'm not sure exactly what you're referring to, Ferris. That might be a name for a feature that was there but not called that the last time I tried it out, which was a while ago. Basically, it did generate stubs. Oh, I see. New tool. Okay. Yes. So the tool that I used, the Parasoft tool that I used, had the ability to generate stubs that would kind of simulate the stuff that wasn't there. So it's sort of what you're talking about, though it sounds like they've done some work on it. Anytime you're testing with some sort of simulation or stub, it's better than nothing. But there, in my experience, are always defects that can only be discovered when you're testing with the real stuff, the real software, the real hardware. So if the simulation allows you to test something in isolation because you want to test it in isolation, that's great. Simulation allows you to test something earlier than you might otherwise be able to test it, that's also great. But never make the assumption that the testing of the simulation excuses you from testing the actual integrated, fully integrated thing. So basically, what I'm saying is that the last build that in the integration test process should be everything together, and then you focus on testing of this integration of it. Farrah says, perfect, that's what I wanted to hear. Thanks. You are quite welcome. Good luck with that. Ferris also says, thanks, Rex. Great presentation. Very helpful. Glad to hear that. That's always our aim, is it be helpful stuff. Daniel says, great. Thanks for your answers. Just to continue the topic, what is the starting point for integration tests? Code, requirements, modules? Yeah, so this is the question of, what's the first test basis element really that would allow us to get started. Now, from a point of view of planning, I mean, you can start to do planning for integration testing in parallel with the requirement specification phase if you're doing a sequential life cycle or inception period in Agile. As far as the details of when you can actually start to create, design, and implement the tests, you're probably going to need at least a high-level design before that can happen, and maybe even you have to start seeing some of the code itself. So kind of depends. Now, setting up your environment might be something that can start well in advance of getting the detailed design, because you might know what you need to sort of dummy up things. Okay. Got an email question here. Can I participate effectively in integration testing if I'm not very technical? Well, it's difficult. I mean, I just looking at the attendee list, I noticed that we had a fairly significant drop-off in terms of attendees as soon as I put the code up. As soon as I started talking about that design predicates and caller-callee relationships and showed that code, some number of people just dropped off because they look at that and say, I don't get it. I can't read code. I don't do code. The thing that I suspect is that over time, and we're already seeing this, this is a trend over the last 10 years that has been accelerating, that more and more people are looking for testers to be technical and testers to be able to program. And I've got a number of very talented associates who have had a lot of difficulty getting contract work lately because they simply don't have adequate programming skills in spite of the fact that they have excellent testing skills and have been doing testing for years. Now, is sometimes a case of people doing the hiring that have a bias towards just an assumption, oh, well, testers need to program even though they actually don't. In other words, it's, the tasks that the person will ultimately be assigned have nothing to do with programming. Well, yeah, that certainly happens, but I wouldn't count on that. I mean, I think more and more the request that the testers have technical skill is one grounded in reality. And certainly my background as a programmer has always been helpful to me as a tester because it helps me understand why things are happening and thus helps me do a better job of isolating and pinpointing why there are certain kinds of defects. So if you do not know how to program and you're in the testing world, I would highly encourage you to go and learn it. It is not that hard. Do not be intimidated by code. You could just learn a simple scripting language to get started and then move on from there. Okay, let's see. So Ferris got a follow-up comment. Just Google BattleMap, tool that you mentioned for automatic generation of tests. Okay, you couldn't find anything. Did I misunderstand what you said? Could you please repeat the name of the tool? BattleMap is indeed the name of the tool, but BattleMap does not, to my knowledge, do automatic generation of tests. At least I've never thought that was a feature of it. I believe that what BattleMap does is cyclomatic complexity and integration complexity, and it might do code coverage analysis, but I'm not sure of that. I wouldn't bet on it. I think code coverage would have to be done separately. Okay, so to close this session, let me tell you a little bit more about the resources available through RBCS. We run these free webinar sessions once a month. You check our website, rbcs-us.com, to sign up. If you want a special webinar presentation for your company only of this webinar or any other topic related to software testing, send an email to info@rbcs-us.com or contact us via our website. If you don't already receive our regular free newsletter, you can sign up at, again, rbcs-us.com. By signing up, you'll get valuable discounts on consulting and training services along with a regular newsletter. The newsletter has featured articles on software testing and quality and news about what RBCS and its partners are doing lately. You can follow us on Twitter, twitter.com/RBCS. We are at RBCS. And on Facebook, facebook.com/pages/RBCS-INC. Remember to check your email over the next couple days. You might be the lucky winner of a free e-learning course from RBCS. You are registered for a random drawing for such a course simply by attending. Check out my blog, rbcs-us.com/blog. Feel free to post comments on anything that you see there. If you don't see something interesting that you'd like to discuss with me, send an email. The email should go to info@rbcs-us.com. And maybe put blog in the subject line and what you want to discuss, and I'll try to get to that as soon as I can. The blog gets updated basically as time is available, so it can be kind of stop and start, if you will. But I do get to it. Finally, check out our digital library. And you can see recordings of these webcasts, podcasts, videos, and more. Subscribe to the podcasts via iTunes by entering RBCS Podcast into the search string, and see videos of recorded podcasts by subscribing to the RBCS channel on YouTube. Let's see. It's the Carmen makes a last comment here that I want to mention right before we go. So the battle map tool is now included in McCabe IQ Test Team Edition, so might be something that you might be interested in taking a look at. So that concludes the webinar. I'd like to thank everyone for joining us today. Remember that we offer these free resources as a service to you, the software testing community, because at RBCS we're a not just for profit company.